Today we're going to be looking at Section 3, it's Chapter 11, Section 3, and it's called Boyles Law. We're going to look at several different laws this chapter, and this is the first one. So what we're looking at is we're looking at this picture right here, and it says what is happening in the picture to the side. Use the terms pressure and volume. So we're going to look here, and you can see the picture, and you can see how this piston is, they have risen it, so you can see how much space you have, and then you can see as you push the piston down. Now I'm going to be doing stuff like this with water bottles in here and balloons so that they can visually see what's going on, and give them each their own balloon so that we can see how pressure and volume are related. So if you look, and then down here they have numbers for them. The volume, you can see the volume has went from 4 to 2. So the volume has decreased, and when the volume decreased, let's look at what happened to the pressure. The pressure increased. So that's going to be the big thing here. What is happening in the picture to the side? Use the terms pressure and volume. So as volume decreased, pressure increased. All right, so this Boyles Law is dealing with pressure and volume. So Boyles Law can be stated as, and let's use kind of the book version of this answer and we'll explain it. The pressure of a gas is inversely related to its volume as long as temperature, and I'm going to write in, that means amount, like how much gas you have, as long as they stay constant, which means I'm not changing the temperature, I'm not adding or taking away gas from this. That's what's happening. Now, the actual math equation that we use is P1. We usually write it as a little subscript, P1, so your initial pressure multiplied by your initial volume is going to equal your final pressure times your final volume. So it's really easy. These math problems are pretty simple. They will give you 3 of the 4, and then you just have to solve for the 4th, the unknown. So they might give you pressure 1, volume 1, and then they might tell you your new pressure, and you have to figure out what your new volume is. Or they may give you the volume and you have to figure out what your new pressure is. All right, so that's Boyles Law. So knowing this inversely related, what that means is as one goes up, the other goes down. They're opposite of each other. So knowing that, let's look at this chart. We're just going to predict what will happen. So I have my pressure 1 and I have my pressure 2. I want to try to predict what my volume is going to do. So if my pressure has decreased, then my volume is going to, that is right, my volume is going to increase because they are opposite of each other. All right, now volume on this second one, I've got both of my volumes, and I can see that my volume has increased, which means my pressure is going to decrease. And then finally on the last one, I have both of my volumes here. I need to figure out what my pressure was. So 5 to 10, that increased, which means that my pressure decreased then. Which means this number right here is actually going to be more than 5, right? If I had 10 here, 10 to 5, that decreased. And I can't type apparently. There we go. Okay, so Boyles Law in breathing. We can breathe because of, we breathe because of our diaphragm, that muscle underneath our lungs, but Boyles Law explains how we're able to breathe and what's happening to the air. So, and I'll say this again, this diaphragm, you can kind of see this pink kind of muscle right here. That's what's causing this all to happen. So what happens when you're inhaling right here, this is inhaling. You can see air inhaled in. What happens is your diaphragm relaxes, and when it relaxes, like right now, if you were to inhale, go, when you inhale, you can feel almost like your rib cage get bigger. And that's because your diaphragm relaxes, and when it relaxes, it causes your the volume inside your lungs increases. All right, that muscle goes down and your lungs can get bigger. So the volume increases, causing your pressure then to do the opposite, causing pressure to decrease. So in this picture right here, and look at the lung size in both of these pictures. Your lungs are bigger, the volume's bigger, so the pressure is low in here. Now on any air, any kind of diffusion, any air, it will move from high to low pressure, causing air to flow into the lungs. All right, so what happened here is your lungs got bigger, the volume increased, pressure decreased inside there. So now the pressure inside your lungs is lower than the pressure of the air outside your lungs. So it's not like you're sucking in air. What happens is your diaphragm relaxes and air just naturally flows into your lungs. So when you're exhaling, it's the exact opposite. Look at your lungs. The diaphragm is pushing up on them. So even when you go, like blow air out, it's almost like you can feel that diaphragm squeeze up. So what happens here is the volume inside the lungs decreases, and you can see that in that picture. They're smaller, causing pressure then to do the opposite. Once again, my pressure now is more inside my lungs than it is outside of my lungs. So air will want to flow out because air moves from high to low pressure, causing air to flow out of the lungs. Now remember, this all happens because of your diaphragm. If something happens to that diaphragm and you can't cause that pressure change or that volume change, then you're going to be in some trouble. All right, so let's watch this YouTube.
Good grammar and spelling are important, but if you want to write essays that inspire...
Today on Sci Guys, Boyles gas law.
Now at the end of this chapter, we will have stations set up where this is going on, and if you're a learner, you'll take those notes and use them in your classroom.
Welcome to Sci Guys. I'm Ryan.
And I'm Mark, and today we'll be starting our 3-part series on the laws of gases. Today's episode, Boyles Law.
Under pressure.
Just Shazam it, it'll know. Boyles' law states that in a closed system, pressure and volume are inversely proportional. What that means is that as pressure increases, volume would decrease, and vice versa.
The only equipment you're going to need for this episode includes a large syringe that you can get at a medical supply store or drugstore,
And water balloons, which we found to work well because of their small size. Although we're not dealing with anything hazardous in this episode, it's never a bad idea to wear some eye protection and a lab coat or apron. The first step in our experiment is to blow up our water balloon. Keep in mind how large it is, as it still has to fit inside the syringe. Once you have it to a good size, just tie it off, like so, and you're ready to go.
The next step in our experiment is to take your small balloon and your large syringe and drop the balloon inside the syringe and place the plunger on the end. For our first test, place the plunger at the highest point in the syringe and cover the bottom opening with your finger. Next, press the plunger down and watch as the balloon shrinks in size. Remove your finger from the bottom of the syringe to release the pressure. For the second test of our experiment, we're going to place the plunger at the lowest point it can be without touching the balloon. Once again, place your finger over the opening in the bottom of the syringe and pull the plunger upwards. Watch as the balloon increases in size. To release the pressure, remove your finger from the opening in the syringe. Let's look at this experiment a little closer. Boyles' gas law states that when a fixed amount or mass of an ideal gas is kept at a constant temperature and in a closed system, then its pressure and volume are inversely proportional. What this means is, when pressure increases, volume decreases, and as pressure decreases, volume increases. An ideal gas is a theoretical gas composed of a set of randomly moving, non-interacting particles. Under normal conditions, many gases such as oxygen, hydrogen, and some heavier gases like carbon dioxide will behave like an ideal gas. This means they follow the laws of ideal gases, such as Boyles' law. In our experiment, the balloon and syringe are filled with tons of gaseous air molecules. Placing your finger over the opening at the bottom of the syringe keeps the mass of air molecules constant and creates a closed system that will allow us to manipulate the pressure and volume. When we press the plunger down, we are increasing the pressure being placed on the air molecules inside the syringe by reducing its volume. As the pressure increases, the amount of force placed on our air molecules increases and they are forced closer and closer together, decreasing the volume of space that our gas takes up and shrinking the size of our balloon. When we remove our finger from the bottom of the syringe, we release the added pressure and our balloon grows back to its original volume. In the second portion of our experiment, we start with the plunger at the bottom of our syringe, almost touching the balloon. When the plunger is pulled upwards, we are reducing the pressure inside the syringe by increasing the volume of space the air inside takes up. This decrease in pressure and increase in volume pulls the air molecules further apart, increasing the amount of space the gas takes up, growing and expanding the size of our balloon. Removing your finger from the bottom of the syringe returns the pressure back to normal, reducing the volume and size of our balloon. When we compare the two variations of this experiment side by side, we can clearly see the inversely proportional relationship between the volume and pressure of an ideal gas. This relationship is known as Boyles Law.
Well, that's it for episode 1 of our series on gas.
Alright guys, so like I said, we will see some of these at the end of this chapter where you guys will have stations that you will perform some of these and you'll need to know what law we're talking about. Alright, so let's go back to the notes. We have some learning checks here. So the first learning check says, for a cylinder containing helium, indicate if cylinder A or cylinder B represents the new volume for the following changes. So here's what I have. I want to know, after I decrease the pressure, will it look like cylinder A or will it look like cylinder B? Well, if I'm decreasing pressure, that means I've increased my volume, right? And look at A and B. B has an increased volume. So the answer for number 1 is B, which means that on number 2, if my pressure increases, my volume has decreased. So my volume has decreased in A. So number 2 is A. All right, the next learning check is going to be a math one. Now remember, pressure 1 times volume 1 equals pressure 2 times volume 2. So let me write that up here real quick. P1 times V1 equals P2 times P2. Sorry guys, that is not very good writing. Okay, so anyways, I will tell the kids in class that they can write this down on their periodic table, which it's nice to have all your important things from every chapter in one spot. So even though you're at home and you may be like, well, I have all this right at my fingertips, like go ahead and write it down on your periodic table. All right, so what I have here is I have, if the helium in the cylinder has a volume, so there's my V1 right here. And I always do this. I always write this down above, like as I'm doing problems, I'll write this down above here, wherever my numbers are. And there's a pressure of 850 millimeters of mercury, so that's my initial pressure. What's the new volume? So I'm looking for V2. When the pressure has changed to 425 millimeters of mercury inside the cylinder. So I've got my V1, my P1, I've got my P2, I'm just searching for V2. Now the big thing that I need to make sure here is that this right here, not that, millimeters of mercury is the same, that these two pressures have the same unit. Sometimes they will try to trick you and give you like ATM here and millimeters of mercury here, and then you would just have to choose one of them to change. It wouldn't matter which one you choose. Same with volume, which we'll see in a second, so I won't talk about that. So I'm going to go ahead and set this up. I've got 120, let me do this, 120 times 850 equals 425 times V2. All right, so that's how it's set up. P1, V1, or you could say V1, P1, doesn't matter which way you put them, equals P2 times V2. So now to solve for my unknown, my V2 right here, I'm going to have to divide, see if I can figure out how to do this here. If I can underline, yeah, I can underline that. So what I'm going to have to do here is I'm going to have to divide by 425. on each side of that equal sign. Okay, so what this does is it cancels those out, leaving you with your volume. So I'm going to take 120 times 850 and then divide by 425. Now what this equals, when you plug that in, is 240 milliliters, which is number 3 here. All right, the next learning check is not a math problem. It's kind of similar to this first one up here with the cylinders. It says a sample of helium gas in a balloon has a volume of 6.4 liters at a pressure of 0.7 atm. At 1.4 atm, is the new volume represented by balloon A, B, or C? So this is my balloon that I have right now. I change the pressure. It goes from 0.7 to 1.4. They want to know, what does my balloon look like? Does it stay the same at B? Does it get smaller or does it get bigger? It's similar to what they just did in the video. So if my pressure has increased, my volume then is going to decrease, which means that it is going to look like balloon A. The volume has decreased. All right, let's go down to this next learning check. So this is basically the same problem with the balloons up there. It is the exact same problem. It's just now they want to know, what is your new volume? So I've got my volume, my initial volume. I've got my initial pressure, my V1 and my P1. And now make sure that these match, ATM and ATM, so I don't have to do any conversions. This is P2, so I need V2. So what I'm going to do is I'm going to say, okay, 6.4 times 0.70 equals 1.4 times V2. All right. So now to get my new volume, I need to get, that should be 1 point. I know that 1.04, okay. So I'm going to divide each side of this equal sign by 1.04. 1.04. Okay, so what that does is that cancels out this side, leaving me with my new volume. And I'm going to take 6.4 times 0.7 divided by 1.04, and that equals 3.2 liters. Now it's in liters. If you look up here, this one was in milliliters because that's what the problem gave us. This one we started with liters, so my answer will be in liters. I could change it, I could convert it, but they don't ask me to. So my answer is going to be A. All right, and then finally, here we go, our last learning check. A sample of oxygen gas has a volume of 12 liters, so there's my initial volume, and at 600 millimeters of mercury, so that is my initial pressure. What is the new pressure when the volume changes to 36 liters? So I've got a new volume. So here's my V2, I want P2. So I'm going to do what I just did above. I'm going to take 12 times 600 equals 36, and I need to find my new pressure. All right, so to find my new pressure, I need to divide by 36 on each side of the equal sign. What that does is that cancels out the 36 here, leaving me with my new pressure. So I'm going to take 12 times 600 divided by 36, and that is going to equal 200. Now, it's going to be in millimeters of mercury because that is what my initial pressure was in. So the answer to this would be A, or number 1, I guess, 200. All right, guys, so you will have a worksheet to complete tomorrow on this. Let me know if you have any questions or if you need anything from me. Have a great rest of your day.